posters. So here, this is a problem about a poster that's supposed to have the bottom and top margins are 6 centimeters, side margins are 4 centimeters, okay? And they're telling me that the printed material is 384. So that means the stuff in the middle, like this, that's 384. So as soon as you see that constraint, I'm going to suggest that you say, okay, let's let that be x times y. So I'm going to put x here and y here. Then I'm going to put the parts with the margins off of that. So we have top and bottom 6. So 6 here and 6 here. And then we've got 4 centimeter margins. So 4, I'm a really different color here. Okay, 4 and 4. Okay. So notice how I made the constraint a really easy thing. Isn't it been nice, or hasn't it been nice, to have this to be easy to substitute in? So I want you to keep that in mind. So if I look forward to this one, the whole area of this poster is supposed to be 180 inches. So this whole thing, x times y, is 180. And then they give us the margins. And then they want how to minimize or maximize this area. So keep the constraint a nice, easy thing to use to substitute. Okay, so if I go back to this one, so the area, the smallest area, so if this distance is x, this whole distance will be x plus 8, correct? And if this distance is y, this whole distance will be y plus 12. Whoops, 12. Then I substitute x plus 8, and then 384 over x plus 12. And I'm just going to do the product rule. It doesn't really matter, right? A prime, so first, d second. So that gives me negative 384 over x squared, and the derivative of 12 is 0, plus second, d first, 12, times 1. Okay, so then let me make some room up here. Okay, so then now I'm going to multiply it out. So if I take these two and multiply them out, you see how x's cancel, right? So I would get a negative 384 over an x, and then this times this, and I'm not even going to multiply it, right? I'm going to say a minus 8 times 384 over an x squared, and then this gives me a plus 384 over x plus a 12. Let me make some more room. Plus a 12, and it all equals 0. Will you look at that? Let me get rid of that. I think I see lots and lots of things canceling. This cancels with this, right? And if I move this to the other side, I get 12 is equal to 8 times 384 over x squared. And then I can continue on, multiply by x squared. So x squared is equal to 8 times 384 over 12. All right, so using the calculator, I get x squared is 256. Oh, will you look at that? So x is 16. So then if I wanted to find the y value, I'd plug it into here. So 384 divided by 16 gives me 24. So there it is, 24 by 16 for this problem, right? This one here, let's set it up. So I'm going to have, that's the area of the whole thing. So if I want to find out the area of this region in here, let's look at what the margins are. 1 inch at the bottom and the sides, right? So 1, 1, and then 2 inches at the top. So then the area of this red part here would be x subtract 2, right? X subtract 2, and then y subtract 3. So then I would take this, solve it for, I'm just going to solve it for y. And I get 180 over x minus 3. And then you could choose to multiply this out or do the product rule. I'll just do the product rule first. D second, so negative 180 over x squared, and derivative of that is 0, plus second, and then d first is 1. And I'm going to let you finish this one off.